Now this illustration deals with routing and sizing in accordance with NEC 250.24 C as in car 1. Now notice we're going to route the grounded conductor from the transformer through the meter to the main and connect to the grounded bar that you see commonly connected to ground there. Now, that's the routing of the supply side. That's just routing so far. And that's 250.142A1 that works hand in hand with 250.24 C as in car 1. Now on the right-hand side, we're on the load side. We have an overcurrent device ahead of those conductors, so the equipment ground has to be routed from the service equipment grounded bar and connected to the metal enclosure of the equipment. That's routing. Now we get to sizing. So again, let's keep this consistent. 4 coming from the transformer, routed through the meter to the panel board main of 225 amps, 4 Then you see in the illustration to the left, up toward the top, right below the building arrow, it talks about 250.102C1. So we would take the 4 as we previously have stated a number of times, and that would be a number 2 routed through the meter and connected to that grounded bar for an effective ground fault path, and that's sizing. Then if it's used as a neutral, we'd have to go to 220.61 and calculate it for a neutral. Now, for example, number 2, based upon the 4 is large enough for an effective ground fault path for fault current. But it might require a 1 calculation for 150 amp neutral in accordance with 220.61. We could have L1 150 and L2 120. It'd be an unbalanced, see? So it'd be an unbalanced about 10 amps. So we would have to size it for the 150. So that's sizing. Now on the right-hand side, we have an overcurrent device there. And if the overcurrent device was 200, or let's just say something more logical like 100 amp, then I believe you would have a number 8 equipment ground sized off of a 100 amp breaker in accordance with table 250.122 or whatever size that breaker of 100 amp required from table 250.122. And if it was, say, number 8, then that would take care of it. Now, that would be the same if you had, say, a metal conduit. It's just that 250.118 gives you a metal conduit for an equipment ground and an equipment ground. Meaning what? If you go to the University of Georgia site for testing equipment grounds, that metal conduit will pull about 90% of a fault, good rule of thumb. Equipment ground only pull 10%. But if any reason the metal conduit did not pull the 90%, but only pull 70%, the equipment ground now would pull 30%, and it would pull any amount. Say that you had 100% restriction, then the equipment ground would pull 100%. So 250.118 allows redundant grounding in that manner, I call it. And what this illustration now is showing, routing and sizing in accordance with 250.24C1 and C2, as well as table 250.102C1 for supply side grounding and bonding, and table 250.122 for load side. Then once again, we give you all of these sections to tie you directly to a section that deals with what you're looking for, either wiring methods, driven rods, water pipe, whatever you may be wanting to ground to or supplement, whatever you might be wanting to accomplish, concrete, encased electrode. Notice all of them are listed there, building, steel, the whole thing. So we still give you all this information, but the main thing here you want to get down, not that you don't have it, is there is a routing requirement and a sizing requirement, and you've got to look at 250.24C1 and C2, as well as Table 250.2C1 and Table 250.122, and then for your grounding electrode conductor, Table 250.66, and that's what this illustration in Figure 16-27 is illustrating.